Good morning and welcome to our lesson today. Now, we are still on energy and what it can do for us. This time round, we want to look at light and probably find out a few characteristics of the same. I want us to look at reflection of light. In this case, we are going to be concerned about light as a form of energy. A reflection of light image formation as well as characteristics of the images. We are going to look at those four. First, we will define light as a form of energy. This time, we do not want to change it into any other form. Rather, we want to find out how is it applied when we are forming images as a result of reversibility of the path of light, a concept we are going to call refraction. A reflection which will entail how a path of light can actually be reversed. Talk about the images that will be formed thereof and give them a few characteristics. Now, probably we can start by looking at light. And light, we define it as a form of energy that allows us to see. Now, you realize that for your eyes to be able to see or perceive whatever it is that you're looking at, there has to be this form of energy that is going to be directed to your eye from the object that you are observing. The same is going to be reflected back, and in that way we can form an image of whatever you are looking at. Now, light can also help us in the process of photosynthesis. It has also been applied in very many areas. For example, we have the reflectors, or what we call the side mirrors. We have also what we call the shaving mirrors. We have instruments like, for example, the microscopes. We have telescopes, and the list is endless. Now, let us look at reflection of light. Let us look at reflection of light. Let us look at a reflection of light. And this in itself is the sending back light, the sending back of light. Now, let us look at something like a plane mirror. As a plane mirror. Then we consider a ray of light that is actually incident at this particular point of the plane mirror. Let us assume this is a plane mirror. Then we have this ray of light incident at a point on a plane mirror. Now, this ray is going to be reflected in some way that we are going to look at, and is equally going to observe some laws of reflection, which I will require us to remind ourselves. On the laws of reflection. Now, number one, we have three rays that we consider when we talk about the laws of reflection. Now, we have one we call the incident. We have the incident ray. We have the normal. Have the normal ray, and we have the reflected ray as well. Now, these three are the most important that we put into consideration when we are discussing reflection. Now, this one is the ray from the source of light. This is the ray from the source of light, be it an object that we want to observe or whatever it is that is producing the light that we are holding into consideration. This one is perpendicular to the reflecting surface at the point of incidence. It is actually perpendicular to the reflecting surface at the point of incidence. I will actually illustrate that as a form of diagram. Now, again, we have the reflected. It is the ray from the reflecting surface. In this case, we took our plane mirror to be our reflecting surface. We have these three rays. One is a ray that comes from the source and which we want to see how it's going to behave when it falls on our reflecting surface. We have the normal, which we draw perpendicular to the reflecting surface at the point of incidence. And again, we have the reflected ray, which we are going to consider as the ray that comes from the reflecting surface. Now, I want to draw the three so we can see the relationship that exists among them. John, iko wapi ruler? So we can find out the relationship that exists between the three. Now, let's take this to be our reflecting surface. That is our reflecting surface. For example, we can consider a plane mirror. Then this one is our incident ray. Please note the direction of motion of that ray. It's very important. Then we have the normal. And again we have the reflected. We have the reflected ray. Now clearly you can see that the incident is coming from some distance to our reflecting surface. We have one perpendicular to the reflecting surface at the point of incidence of our first ray. And then we have a reflected ray that is coming from the reflecting surface and towards our eye. Now, again, we should look at these angles. Let us call this I, and this one we can call it small r. Now, those angles are equally very important when we are talking about reflection of light because the incident ray, we start by defining it as not ray but angle. The incident angle is the angle between the incident ray and the normal. It's that angle which is between the incident ray and the normal ray, this one here. We have our incident ray, we have our normal, then we have the angle between them, which we call the incident angle. Now, we also can talk about the reflected or the angle of reflection. Again, we will define it as the angle between the reflected ray and the normal. This one here that we are calling capital R, this angle between the two rays is what we call the reflected angle. Now, having understood the diagram, we can now come to the laws of reflection. The laws of reflection. And we have basically about two. Number one, the law number one states that the angle of incidence, which we are calling small I, and the angle of reflection are always equal. The angle of reflection again is denoted using small r. So the two are always equal. Therefore, in symbols you write I is equal to r. That is the law number one. Number two talks about the three rays, and it states that the incident normal and reflected rays at the point of incidence all lie on the same plane or lie on the same plane. That the three important angles that we have looked at are the point of incidence will always lie on the same plane. And then the next law is the one that gives us the relationship between the angles, and basically it suggests that our two angles are actually equal. Now, back to our curved surfaces. And we want to find out what are the methods of making curved reflectors. What are the methods of making curved reflectors? And basically, we have two methods. Number one, we have what we call polishing. And number two, we have what we call silvering method. We have those two. Now, depending on the curved surface that you want to come up with, you will actually decide on which method you really are going to apply. Now, out of the two, we can come up with the following types of reflectors, depending on the method we use. Number one, we have concave, or what we call converging surface or a reflector. That is one of the types of curved surfaces that we have. And this one converges. It converges the rays of light incident on it. It converges. Converging means bringing together. For example, if you had a beam of light, which is actually parallel like that, incident on it, upon reflection by this our converging surface, they will actually converge. If you had a parallel beam like that, and then let us assume that this one is our concave reflector. Upon reaching our concave reflector, we will expect that the rays will converge at a point. They will actually converge at a point. Now, if we were to have our reflecting surface at this point, the rays that come incident and parallel to the reflecting surface, which is the whole of this line, are supposed to be reflected in such a way that they meet at some point. They meet at some point. Now, converging is actually the idea of rays meeting at some point after meeting at some point after reflection. That is what we call converging. You can still call it merging, courtesy of our converging lenses. Now, a converging reflector is formed when we polish. A converging reflector is actually formed when we polish the inner part of a curved surface. Remember, we have two methods. We can have polishing and we can have silvering. Now, if we choose to polish the inner surface of a reflecting of a curved surface, we come up with a converging reflector. We could also silver the outer surface of a curvature. We could also silver. So either way, whether we polish the inner part or we silver the outer part. Now, remember, if you want to polish, it's the inner part or the inner surface of your curved or of your curvature. But if you choose to settle on silvering, then you consider the outer. the outer surface of your curvature. Now both will give you, they will give you a reflecting surface like that, and that is what we call, this is the highly polished. It's the highly polished surface, leaving the outer as our concave reflector. Now the second type is what we call the divergent. Diverging or the convex reflector. The diverging or the convex, and as the name suggests, it diverges. This one actually diverges. It diverges rays falling on it from a source. It actually diverges or scatters. It scatters. So that in case of a parallel beam of light from a source falling on this our reflecting surface, it is actually going to be scattered in different directions. Let us try and illustrate that as well. Assume that this one is again our reflecting surface. If that should be our reflecting surface, then these rays, which are actually incident on our reflecting surface, are supposed to be reflected in such a way that they are scattered in different directions. They should actually be scattered in different directions. But there will be one at the center. There will be one at the center which is reflected on its own path. Now, how can we come up with this kind of a reflecting surface? It is actually a convex reflecting surface is made by a polishing the outer surface, or better still, silvering the inner surface. You can actually polish the outer, or you can silver the inner. In both cases, you will have succeeded in coming up with a convex reflector. A convex reflector, where this one is now the highly polished surface. Now, there is another one, the last type of reflecting surface. The last type which we call parabolic reflectors. And a parabolic reflector is a special, it is a special reflector formed from a section of a cone. From a section of a cone. A cone looks like this. Now from this, you can decide to cut any part. For example, if you cut longitudinally, you can come up with such a surface, and depending on which side you polish or silver, you again can come up with different reflectors, which could be concave or even convex, but provided they are formed from a section of a cone. Now they are called parabolic reflectors. This one is a concave parabolic reflector, and equally this one is a convex parabolic reflector. So depending on which part of the cone that you cut and how you silver it or polish it, you can come up with any of those two types of parabolic reflectors. Now, we want to define some terms. In the course of studying our reflecting surfaces, we are going to come up with a few terms that we are going to interact with, and it is good that we understand each one of them to avoid confusion. Now, we look at some of these terms and again try to come up with their definitions. Now we consider a converging reflector. And its parts and find out what they actually represent. Let us look at some rays which are parallel and incident on our converging reflector. Now, these rays, as we looked at, are going to be reflected in such a way that they are going to converge at some point. Let us consider these two. We have this one and the second one. They are going to be reflected in such a way that they are going to meet at some point before they diverge again. Now, this particular point here, which we are calling F, we are going to call it the principal focus. Principal focus, or the focal point. The focal point. The principal focus, or the focal point. And this one is the point at which rays incident and parallel to the principal axis. The principal axis converge after reflection. That we have a parallel beam of light that is incident on our reflecting surface, which is concave, concave, and when they are reflected, they meet at some point we are calling F, and we gave it a name, principal focus, or the focal point. Now, that point where the rays will meet before they can spread again is what we call the focal point. Now, it's worth noting that all our reflecting surfaces are actually cut. Reflecting surfaces are cut from a sphere or a cone. Now, if we consider they are cut from a sphere or a cone. Now, if we consider C, which we call the radius of curvature, it is actually the radius of the sphere of which our reflecting surface forms part. That if you were to finish up this drawing, you would actually find out that there is actually a sphere from which we have cut our reflecting surface, and it has some radius, and that is what we call the radius of curvature, which is represented by C, or a small r. Now we also have another point which is equally important, a point we are calling P here, a point P which we call the pole, and the pole is actually the geometric or the geometrical center of the reflecting surface. The geometrical center of the reflecting surface is what we call P, or the pole. Now, there is this line also. There is this line along which R, F, and P all lie. Now we call it the principal axis. The principal axis. And the principal axis is actually the line joining F, C, and P. The line that joins F, C, and P is what we call the principal axis. Now, in our case, this is the line that we are talking about, where our R or C, our F, and our P are joined together. Now, let us look at linear magnification. Linear magnification. And here we consider a comparison between the image and object. Now, at the beginning of the lesson, we agreed that we are reflecting light for us to form some image of the object that we are trying to observe. Now, of course, your reflecting surface is smaller even than the object, but nevertheless, your object is going to have its image formed on the reflecting surface. Now, we want to compare a few aspects of our image relative to that of the object, and in that case, we talk about linear magnification. For example, we can consider image height, and we can divide this by object height. Object height. how many times has our object been enlarged, or how many times has its size been reduced. When we compare the two, we can talk of magnification. Here, the image height could be much bigger or much smaller. Now, depending on the size of image relative to that of object, we can be able to talk about linear magnification. Now, where magnification is less than 1, it means image height is smaller than the object height. Image height is actually smaller than the object height. Now, where magnification is greater than 1, then image distance or image height is greater than the object height. Now, we could also consider another aspect of the same. For example, we could talk about image distance. How far is the image behind the mirror compared to the distance the object is placed in front of the mirror? So, image height over object height. And in this case, the image we call it, the image distance, we call it V. That is the image distance over object distance. We represent our image distance using letter V, and we could also use letter U for object distance. Again, there are times where you find your magnification, that is V over U, is actually less than 1. That means that the image is placed at a greater distance behind the mirror than an object is in front of the same. Now, if the image distance is smaller compared to the object distance, then we expect a magnification that is less than 1. Now, we shall revisit this issue, but just to mention, magnification is represented. Magnification is represented using letter M, that is small m. And most cases we have some formulas where magnification is V over U, where V is the object distance, the image distance, V is the image distance, U is the object distance, and we can equate this to image height all over object height. That magnification is actually a comparison between the sizes of the image and the object, or even the distances of the image and that of the object. Now, Let us look at laws of reflection by curved surfaces. Laws of reflection. We consider four rays and how they are actually reflected relative to each other. Now we again will consider a concave. We consider a concave reflector and look at the four rays of interest that we should be able to find out. Because in the formation of images, by curved reflectors, four rays are considered, and these are the laws we talk about when we are looking at reflection by curved surfaces. We have basically four rays to consider. Number one, we have a ray we have an array through C, or appearing to pass through C. We have a ray through C, or appearing to come from C to pass through C for a convex reflector. And we have looked at C, and we have said it's the center of our mirror. Let us assume we have our principal axis. Here is our C. Here is our F, and then we have our pole. Now, that one is the principal axis, and then we want a ray through C here. Incident on our reflecting surface. This is the reflecting surface. And we have a ray incident to the reflecting surface at some point and coming or passing through C. This ray is actually reflected along the same path. So this is reflected along the same path. So that now, when it is being sent back by our reflector, it will only change the direction, but the path will be maintained. Now we could also consider another ray. Number 2, array through F array through F, and it is reflected parallel to the principal axis. It is reflected parallel to the principal axis. For example, if we have our reflecting surface here, this is F, this is C, then we have the pole, again we have a ray through F incident to our reflecting surface at some point. It is going to be reflected in such a way that it is going to be parallel to the principal axis. Those are about to laws. In our next lesson, we shall look at the next two and probably find out how they are applied in image formation. Thank you.